Let's use an indirect test of validity on two different arguments, one valid, one invalid. First argument we're going to look at, a very familiar valid argument. Here's that familiar argument. P or Q, not P, so Q. We can already test this argument for validity using truth tables. In fact, we already have. Truth tables tell us there's only one way to have both those premises true. That's the third valuation. And where both those premises are true, notice the conclusion Q is also true. That means the argument's valid. Whenever all the premises are true, the conclusion is true. So like I said, we already know that this argument's valid. Now we're going to test this argument for validity indirectly. We're going to assume that there's a validity counterexample and see where that assumption leads us. A validity counterexample, of course, situation where both the premises are true and the conclusion false. So this is what our assumption of invalidity looks like. We start out assuming both the premises true and the conclusion false, and we follow down all the consequences, ultimately down to the level of sentence letters. Assuming the conclusion is false already has consequences at the level of sentence letters because the conclusion is just Q. So we are assuming here that Q is false. That has consequences for the first premise because Q is the right half of that disjunction. We're committed to two facts about that first premise: that the whole disjunction is true, but that its right part is false. We can ask the semantic rule for disjunction what that sort of situation would be like. A situation where the whole disjunction is true, even though the right part is false. There's only one way, the second valuation, where you could have that. And that's a situation where the left part is true. So we've chased down another consequence. The left part of that disjunction, P, must be true. Notice we now have another commitment, another consequence on the level of sentence letters. P is true. We've looked at the conclusion. We've looked at the first premise. Next, we turn to the second premise. We're assuming that that second premise, tilde P, is true. Tilde P is a negation. So we can ask the negation rule what that situation would be like. Negation rule says a situation where tilde P is true is a situation where P is false. So we've chased down one more consequence on the level of sentence letters. In this situation, we're imagining P is false. We started out assuming a validity counterexample, situation where all the premise is true, conclusion false. Wanted to see where that assumption would lead us. This is where it leads us, to P being true and also false at the same time. But that's a flagrant violation of the principle of bivalence. Bivalence says, no, there's no possible way that P could be true and also false at the same time. That means our original assumption must have been about an impossible situation. It turns out there's no possible way to have all the premises true, but the conclusion false. In other words, there's no validity counterexample. That means the argument is valid. Let's review what we did here. We started out by assuming that the argument's invalid. That is, we assume there's a validity counterexample. We use the semantic rules to chase down the consequences of that assumption, ultimately down to the level of sentence letters. What we found in the end is that assumption led to a violation of bivalence, showing us that in fact there's no possible way to have both those premises true and the conclusion false. In other words, there is no validity counterexample for this argument, and that means the argument is valid. Now let's look at a second example, this time a familiar invalid argument. This argument's just like the first argument, except the second premise is P rather than tilde P. Again, we could already test this argument for validity using old-school truth tables. Build truth tables for each premise, for each conclusion, see if there are any validity counterexamples. And there are. That second valuation is a situation where all the premises are true, but the conclusion false. A validity counterexample. So we know that this argument is invalid. Now, again, let's test it for validity indirectly. Start out by assuming both the premises are true and the conclusion false. That is, we start out by picturing a validity counterexample. Follow through all the consequences of that. One consequence right away is that since the conclusion is false, Q is false. That has consequences for the first premise, because Q shows up as the right part of that first premise. So we're now committed to that whole disjunction being true, yet its right part being false. Once again, we can consult the semantic rule for disjunctions to see what such a situation would look like. The semantic rule tells us there's only one way for the whole disjunction to be true, even though its right part is false. And that's if its left part is true. So we've tracked down a consequence. For P, P must be true. Write that consequence on the bottom. Another consequence for sentence letters. Last time we had the problem when we turned to the second premise. Now the second premise is just plain old P. We are assuming that that second premise is true. Look at the bottom there. We're assuming that P is true. We don't get any violation of bivalence here. We've tracked down all the consequences of our original assumption. Each sentence letter has only one value. Does not violate bivalence. Turns out there really is a possible way to have all the premises true and the conclusion false for this argument. Possible situation where all the premises are true and the conclusion false is, of course, a validity counterexample. We've found a validity counterexample for this argument. That means this argument is invalid. Let's review what we did in this second invalid argument. Again, assume that the argument's invalid by picturing a validity counterexample. Again, follow down all the consequences of that assumption by appealing to the semantic rules. In this case, our assumption led to no violation of bivalence. There really is a possible way to have all the premises true and the conclusion false. There really is a validity counterexample. So the argument is invalid. That is the general nature of the indirect test of validity. You start out by assuming the argument is invalid, by assuming there's a validity counterexample. Next, you use the semantic rules to chase down all the consequences of that assumption. And then when the dust clears, you see what's happened. If the assumption led to a violation of bivalence, then it turns out there really isn't any possible way of having premises true and conclusion false. There really is no validity counterexample. So, if the assumption leads to a violation of bivalence, that means the argument is valid. On the other hand, if, after following through all the consequences, we find no violation of bivalence, well then, that situation where the premises are true and conclusion false, that really is possible. There really is a validity counterexample. So, if there's no violation of bivalence in the end, the argument is invalid. That's the general pattern in an indirect test of validity.